Assalamualaikum and a very good day to my fellow panels. I am Nisa Karmila binti Kamarulzaman from AS244 and I'm going to present my final year project entitled The Isolation and Identification of Microbiota from Cincalok. For today's presentation, we're going to start with introduction and will be ended with references. Cincalok is a famous traditional Malaysian fermented shrimp paste that are widely consumed by the locals. According to Arya Kiasami 2019 and Noviani et al. 2051, there are several types of fermented shrimp paste in other Southeast Asian countries such as Cincalok from Indonesia, Kapi from Thailand, and Pala-Pala from Philippines. Cincalok is generally made using small shrimp or krill mixed together with coarse salt and cooked rice. According to Sofiana et al. 2020, all of these ingredients are stored inside a container for a few weeks or months for anaerobic fermentation process to take place. According to Helmenstein 2020, the anaerobic fermentation process involved the breaking down of molecules like glucose into a simpler compound with the help of microorganisms without the presence of oxygen. Based on a study by Lee et al. 2021, the naturally occurring microbiota often survive in the end products of Cincalok due to the rarely performed sterilization throughout the process of making it. This allows the growth of microbial diversity. Raw materials that are contaminated by harmful microorganisms will result in unsafe products, which brings us to the problem statement of this research. In this study, some low-quality Cincalok products may contain harmful microorganisms such as E. coli, B. cereus, and S. aureus. Moreover, the lack of study on the bacterial composition and the microbiota presents in the Cincalok also contribute to this study. The general objective of this research is to study the presence of bacteria from Cincalok. Specifically, this study was to determine and identify the bacteria isolates from Cincalok or nutrient agar, to enumerate the number of bacterial colonies from Cincalok, and to determine the gram-staining properties and morphology characteristics of the isolates. Several procedures were carried out to achieve the research objective. First step involved the preparation of culture media, followed by sample collection and preparation. Then, the isolation of samples was proceeded, followed by sample screening by bacterial enumeration and purification of bacteria. Then, sample identification was conducted through gram staining, catalyst tests, and indole tests. The entire procedures of this study involved 3 replicates of 2 different samples, X and Y, each of which was incubated for 24 hours. Table 1 and 2 shows the bacteria isolated from sample X and Y respectively. The plates with dilution factors of 10-1 had the highest numbers of colonies, indicating a higher initial concentration of bacteria in the samples. In contrast, plates with a dilution factors of 10-4 exhibited the fewest colonies, suggesting a lower concentration of viable bacteria. The reduction in colony count indicates that as the sample were further diluted, the concentration of bacteria decreased. To achieve the first objective of this study, a total of 3 pure cultures were obtained. 2 different colonies from sample X, labeled as X1 and X2, and 1 colony from sample Y, labeled as Y1, were subcultured into new nutrient agar plates. The pure culture of X1 is shown in Figure 1. It is spherical, extremely tiny in diameter, slightly raised, and translucent. Figure 2 shows the pure culture of X2, which has the characteristic of round shape, slightly raised above the agar, and pale yellow in color. The pure culture of Y1, shown in Figure 3, exhibit a round shape and small in diameter with an opaque creamy white color. The second objective is achieved by conducting bacterial enumeration. Table 3 and 4 presents the colony count and the CFU per mil values for each plate of sample X and Y respectively. Plates with first, second, and third dilution exhibited an excessive number of colonies, classifying them as the MTC. However, plates with fourth dilution had colonies within the countable range. For sample X, the first replicate of fourth dilution had 30 colonies, the second had 2 colonies, and the third had 37 colonies. Since the second replicate had below than 30 colonies, it is classified as TFTC. The first replicate had a total bacterial count of 1.5 times 10-4 CFU per mil, while the third replicate had 1.85 times 10-4 CFU per mil. For sample Y, the first replicate of fourth dilution had 55 colonies, the second had 52 colonies, and the third has 36 colonies. The first replicate had a total bacterial count of 2.75 times 10-4 CFU per mil, the second had 2.6 times 10-4 CFU per mil, and the third one has 1.8 times 10-4 CFU per mil. Gram staining, catalyst tests, and indole tests were carried out on the pure cultures in order to achieve the third objective. Figure 4 to 6 shows the result of gram staining. Sample X1 and Y1 appeared dark purple, Kolker-shaped cells, indicating a gram-positive bacteria. Based on study by Caesar et al. 2022, gram-positive cocci bacteria can be classified into Staphylococcus species and Streptococcus species. Sample X2 displayed a bright red road-shaped cells, classifying it as a gram-negative bacteria. According to Oliveira et al. 2022, there are several types of road-shaped gram-negative bacteria, most of which are grouped under the family of Enterobacteriaceae, such as E. coli, Salmonella, and Enterobacter aerogenes. In order to distinguish between Staphylococcus and Streptococcus species, catalyst test was conducted. According to CBT 2020, Staphylococcus species are catalyst positive, whereas the study by Suvarna et al. States that Streptococcus are catalyst negative. Based on figure 7, there were no change observed on sample X1 and Y1 following the addition of hydrogen peroxide. Therefore, both of them are catalyst negative. However, there is a formation of bubble observed on sample X2, indicating there is an enzyme catalyst activity, making them a catalyst positive. Hence, we can assume that both X1 and Y1 strains are Streptococcus species. To identify which strain of Enterobacteriaceae is sample X2, indole test was conducted. According to Pereira and Amara Sakara 2021, E. coli is indole positive, whereas study by Meki et al. 2021 note that Salmonella, Shigella, and Enterobacter aerugine are indole negative. In figure 8, there is a noticeable color change on sample X2 following the addition of Kovacs reagent. Hence, sample X2 is classified as indole positive organism. Therefore, sample X2 is most likely identified as E. coli. To conclude, bacteria present in the cachalot were isolated and identified in this study. Sample X had an average total bacteria count of 1.68 times 10 negative 4 CFU per mil, while sample Y had a count of 2.38 times 10 negative 4 CFU per mil. 3 pure culture isolates could be classified as Streptococcus species and E. coli based on the biochemical test observation. Hence, this study has successfully achieved all of its objectives. Future investigation incorporated with more advanced technologies such as PCR and sequencing should be applied in order to achieve much precise and valid identification of bacteria present in the cachalot.